This is Sajith K P from the Department of Physics, Silver Hills Public School, Calicut. Wave optics. So, optics we know it is a study of light. So, we know the light actually light makes things around us, the surrounding world very beautiful. So, when light is falling on trees and plants around us, we are able to feel the tenderness of those buds and greenery of that leaves. And when light falls on some lakes and ponds, so it is instant where the surface of that lake or pond gets a serenity of greenish blue or bluish green. So, in that sense that light exhibits many phenomena, and all those phenomena makes the world around us so beautiful. Dispersion and scattering of light and reflection, many phenomena. So, it is told that when the white light, sunlight is prismatically fragmented, then nature opens her rainbow suit consisting of several fabrics of 7 colors. This is nothing but dispersion. So, many other phenomena connected with the light. Now, we know that when light is spreading on the horizon and we are aware of the start of a new day, and of course, we may be, or most of us or some of us sometimes or mostly may be starting the day with a prayer. God, throw light in our path, so lead us through the straight path, don't give any chance for going astray. So, we are praying God to shower light on our path. So, do you have any assurity that, or can we give any assurance that light travels along a straight line? Is it possible? Or sometimes we are saying that throw more light in our journey so that life become bright, but the famous physicist Max Born cautiously warning us that light plus light, it does not give better light, it does not give brightness always. Sometimes that situation may be giving some dimness. Light plus light does not give better bright points. Sometimes it will be dark also. So, this phenomena, how we can analyze this phenomena. See, light plus light, when 2 lights are added, sometimes we are getting darkness. It is not a magic. So, these things can be analyzed by using mathematics, by some reasoning, and there are some theories. In the last class, we have seen the Huygens principles, Huygens theory, and also light. We cannot assure that always light travels along a straight line. So, light can bend. So, we know that process, that phenomena, it is known as diffraction. So, when light is incidentally on a small slit, and scientifically it is proved that, it is observed that if the width of that opening, if it is comparable to that of the wavelength of light which is falling on that opening, which is falling on that small slit, then encroachment of light is happening. Light is encroaching to the geometrical shadow region. So, in that sense light is bending the bending of light. So, how these things can be analyzed? So, we know physics, it is everything. So, physics is it is endowed with the accuracy of mathematics, its precision, and it is a capsule of reasoning and critical thinking and all those things. So, actually a proper dose of that, it is a medicine that can eliminate this ignorance and superstitions, all those things. So, here we are going to analyze this special phenomena. So, light plus light, sometimes that will be creating a darkness and the bending of light. So, first one, the light plus light, that can be bright situations, and sometimes that will be giving some dark regions. So, a light, it is interfering with another light. So, light wave from one source, it is interfering with another light source. So, this phenomenon, it is interference. Of course, we have to explain that interference. So, when and where we will be getting the maximum brightness, and when and where we will be getting the dim regions. And similarly, that bending of light through a small opening or through a small or a straight edge, the diffraction, phenomenon of diffraction. So, how to explain that? So, in order to explain diffraction, we need a small opening, a single minute slit, and to explain the interference, it is a special phenomena. Interference, we need two light waves or two source of waves, light waves. Generally, according to Huygens theory, we are starting with waves on the surface of a homogeneous and isotropic medium. Okay, that can be a mechanical wave, but the way in which it is analyzed, we can make a exact or beautiful comparison with the spreading of light in no medium. Light requires no medium, but Huygens theory, it is explained with the help of a homogeneous and isotropic medium like that. So, we have seen that the concepts of wavefront, wavelets, and some basic terms associated with the waves, propagation of wave, the phase, what you mean by path length or path difference, these things. So, the interference, what is interference actually? So, we can see that spreading of light, spreading of waves, spreading of wave. So, it is a point source. Now, if you are making one more source of one more point of disturbance, means here suppose you may be dropping a stone, and at another place we can drop one more stone and two ripples will be coming. So, these ripples can superimpose each other. So, we know these ripples, the waves. So, here that waves, it is blocked. So, here what we are seeing from the boundary through those openings, again we will be finding ripples coming out. So, each slit, that is each opening, it is acting as a fresh source of disturbance. So, in that sense we have two sources, and these two sources, we know from the beginning those two sources were derived from this single parent source. So, this is the situation. Anyhow, the thing how one wave is, what happens when one wave is coming over the other wave at a single point, at a particular point, there arises many situations. We know in 11th standard we have learned that two types of interference, one is constructive interference and the other is destructive interference. So, usually, so when we are analyzing a wave, so we know when wave is propagating through a medium, the particles of the medium will be undergoing simple harmonic motion, to and from motion. So, here suppose it is up this still water surface and up and down motion. So, one to and from motion. So, we have seen that they undergo simple harmonic motion, or we know the simple harmonic motion, it is a projection of circular motion, we have learnt that. So, in a complete circular motion, we know if we are analyzing it in terms of angle 2 pi radian, and you know this, suppose you are considering a point here. So, this may be the maximum upward, you know, suppose you know you are starting, and then here it will be pi. So, these points, suppose A and B, we can use the term phase difference between them will be pi. So, this can be crest and this can be trough. So, the upward and downward vibrations coming at the same time at a same point simultaneously, that is simultaneous occurrence. So, we know that the crest and trough will be compensated. So, at that region there is no disturbance at all. So, if it is a light wave, high crest means the maximum amplitude is proportional to the intensity is directly proportional to the square of the amplitude. So, there the maximum intensity, maximum brightness. And from the second source also, suppose a second source is there, suppose there is a point P, and from the second source also the wave is coming in such a way that there happens the crest of the second wave, then crest plus crest, a construction is happening. So, that is a constructive interference. But if it is pi and if it is A and B, pi out of phase by pi, then you know that will be destructive interference. Okay, this pi, then one more pi, 2 pi. Then if it is 2 pi, we know crest and crest will come, same condition. So, it is a kind of construction, pi destruction, again one more pi, 2 pi construction, and 3 pi once again. 3 pi means this is topmost point and this is the downward destruction, 4 pi construction, 5 pi destruction. So, all even multiples of pi will be corresponding to constructive interference, and all odd multiples of pi will be corresponding to destructive interference. This, it is a general thing. Now, this other term, path length and path difference. Path length is nothing but the length of the path travelled by a wave. So, here from suppose you are considering point O and A, path length, it is the wavelength itself. So, when one wavelength is completed, if this is the path length, then correspondingly that pi and pi, so 2 pi is coming. So, this is the phase term, usually we are representing phi phase term. So, phase difference or phase term that is represented by phi, and other it is the wavelength. So, if you are taking a ratio of this, that is a ratio of phase difference by path difference. So, that is in the case of full wave, or if you are considering these 2 points, that is 2 pi divided by lambda. So, this is constant for a given wave, known as propagation constant. Okay, that is wave number, it is another we need this only, what is phase difference by path difference. So, the ratio of phase difference, phase term to that path difference term, that is a constant, that is 2 pi by lambda. So, we need this fundamental idea. Now, Huygens theory, and we are going to explain interference. So, any explanation, it needs a theoretical support, and that theory should be supported by mathematics, and it should be verified by experimental evidences. Then it is a successful theory, then it is a successful concept itself. So, here in this chapter we have all these aspects. A theory is taken and it will be supported by a phenomenon is taken and it will be supported by theory. We are explaining it in terms of a theory, and of course, mathematical interpretation is given and an experimental verification also. So, regarding this interference of wave, first of all we have to seek that theoretical support. It is obtained from Huygens theory. Huygens theory, we have learned that the primary source, then wavefront, primary wavefront. So, each point on that wavefront, that will be acting as fresh sources of disturbance. So, we can call it wavelets. Anyhow, those new wavelets starting and the original parent primary source. So, the wavelets are derived from the primary source. So, what all characteristics, specialities this primary source of disturbance is having, then all those points which are present on that primary wavefront, it will be having all those specialities, maybe the frequency, especially the frequency, and maybe if it is somewhat away, amplitude may be damping, that may happen, then amplitude may be decreasing. But if you are considering 2 points or a number of points on a primary wavefront, and all those points will be acting as new sources of disturbances, and all those sources will be emanating waves of same frequency, and their frequency will be same as that of their parent source. Amplitude, that can be different sometimes, but frequency will be the same. So, we need such sources to analyze interference, because there is a technical reason for that. Because we know that if we are taking 2 different sources, in that we have seen that we are taking a source and it is blocked by a boundary and 2 holes are made. So, why can't we take 2 independent sources itself? Suppose 2 bulbs made of same company, same wattage and voltage rating, applying same voltage and the same. So, still we know that the light, it is originating as a result of atomic excitation. So, light essentially it is a small pulse lasting for a short duration of time, maybe 10 power minus 8 seconds or 10 power minus 9 seconds itself. So, if you are taking, even if you are taking 2 sources of same specialities, but we cannot assure that which atom is emitting light at a given instant. Essentially light, it is lasting for 10 power minus 8 seconds, like that only. So, interference, if we wanted to observe it, if we wanted to analyze it, that interference should be a sustainable one. So, if interference pattern is changing with so much rapidity, then we cannot analyze that, or that is not at all observable to human eye. So, we need some sources, and which suppose we are taking 2 sources, then whatever speciality is there for the first source, same speciality should be for the second source. Then always for example, a point P we are considering. So, the first source is sending a crest to that point P within a given interval of time. Then within the same time, the second source also will be touching that point P with the same crest, with the crest. First source is sending a crest to that point P, suppose it takes 1 second. Then second source also touching the same point with its crest, with the crest of its waves. So, in that case we will be having I am using the term coherent sources. So, in that video we have seen that coherent sources are created in such a way. Now, the wave, so first of all let me go for the mathematical treatment. So, we have to analyze it mathematically, and a wave can be represented by a trigonometrical function, because wave up and down motion or left and right. So, amplitude, there is a periodical variation. So, periodically varying functions like sine or cosine can be used in terms of its amplitude of a wave, and then it is a sine function or cosine function of that amplitude. So, let us do that. So, remember what we are going to do. We have seen that if that phase difference is even multiples of pi, then we will be getting better brightness, constructive interference, and if it is odd multiples of pi, the phase difference, if it is odd multiples of pi, then we will be getting destructive interference. Okay, this is the thing we are going to prove mathematically. Then we will be going for its experimental verification. So, first of all, let us take so, let me write the first wave. So, the first wave, let it be y1 is equal to a cos omega t. A is the amplitude of that waves coming from that source, and omega is the angular the frequency time. And the second wave, suppose y1, that is y2 we are taking, suppose it is of same amplitude, but there is a phase difference, a cos omega t plus phi, phase difference. So, the condition to have coherent sources, they should be of same frequency and they should be of same phase, and if at all a phase difference is there in the beginning, then throughout the time of experiment or throughout our analysis, that phase difference should be kept constant. Then we can say still they are coherent. So, there can be a phase difference between these two vibrating sources. Suppose you are taking a water surface and taking two pins, and suppose the pins can move up and down. So, when the tip of the pin is touching the water surface, there the calmness of that surface is disturbed and ripples propagating. So, when the first pin is touching the water surface, at the same time with the same force, the second pin also touching the water surface. So, this pin pricks at the same time, it is made on the water surface. So, the ripples are formed in the same way. So, then there is no phase difference. Now, suppose the first pin is touched and after 1 millisecond the second pin is touched, then there is a time delay. But if this time delay, if it is maintained throughout their vibration, then that phase difference will be kept constant throughout. There is a definite phase relation between these two, then also they are coherent. In this way we can achieve the condition of coherency, but their frequency should remain the same frequency. If two waves are entirely out of that frequency is entirely different, then this coherency is not there, then we cannot observe the interference pattern, we cannot obtain this sustained that sustained interference pattern. It is very difficult, it is not possible. So, here this amplitude, it can be different or it can be equal, no problem, but omega, that frequency containing time, that should be equal. So, I am not going to write omega 1 and omega 2, I am not going to write, but amplitude I can write A1 A2, or A1 can be equal to A2 also, and there is a phase difference. Maybe I told you that 1 millisecond, after 1 millisecond the second pin is touching the water surface. So, that difference, so there is a phase difference, phi can be phi in terms of that phase angle. Now, at a point, so two sources and ripples it is propagating Now, at a point P, two waves are interfering. Then at that point B, suppose it is light source, suppose S1 and S2, this S1 and S2, it is derived from, this like that, it is derived from same parent source. Then if you are keeping a screen in front of that, then depending upon the conditions on the screen, we will be getting darkness at some region, then at other region that will be bright. So, we will be getting concentric rings of alternate bright and darkness, alternate brightness and darkness will be formed in the shape of concentric rings. So, what will be the net result, net intensity or the total waveform? So, let us check. So, the net the total wave at any point on that, that may be the total brightness or the total expression mathematically. So, that will be equal to y1 plus y2, that is A cos omega t plus A cos omega t plus phi. So, now this term we can write it as cos of A plus B, that is cos A cos B minus sin A sin B. So, A into cos A is omega t and B term that is phi. So, A into cos omega t cos phi minus sin omega t sin phi, like that we can split. So, if I am writing like this, then this term will be equal to A cos omega t plus A into, giving A for the entire term, cos A cos B, that is cos omega t cos phi minus, that is A into sin omega t sin phi minus A sin omega t sin phi. So, this is the expression for the resultant waveform, or you can see that here A cos omega t is common from this first term. Suppose I am taking that A cos omega t is taken common and remaining, then it will be 1 plus cos phi, 1 plus cos phi. Then the second term, that is minus A sin phi sin omega t. This is the resultant waveform. But looking at this, we cannot easily, it is a mathematical expression, that expression should tell something, we have to get the meaning out of that. So, here if I am looking at this, I can see the phi containing term, phase time containing term and omega containing term. So, already we know that the condition of coherency is obtained only when, if and only if when those two waves are having same frequency, coherency. So, the condition whatever obtaining on the screen, whether it is dark or bright, it depends upon the phase containing term. Omega is not at all changing. So, no need to bother about omega. So, we can keep it apart, consider isolate the phase containing term only. So, from this expression I can take, this is the phase containing term, A into 1 plus cos phi, that is A plus A cos phi, A plus A cos phi, and here that is A sin phi, A sin phi. So, here how it varies. So, it is a mathematical function, trigonometrical function, it is a sign variation and the amplitude is there. So, generally I can say amplitude is there, it is a cosine variation, cosine function of amplitude. So, I can write that A cos, suppose it is A cos theta, and here suppose we name it as equation number 1, and here A sin phi, we are interested in phi containing term. So, A sin phi, general way you can represent it generally, that is A sin theta. So, that is the nature of that function, and this can be equation number 2. Now, if I am squaring equation number 1 square plus 2 square, then this term actually it is A plus cos theta, A plus A cos theta whole square, and here that is A square sin square phi. This is phi. So, if I am squaring it, then A plus A cos phi whole square, that can be expanded using A plus B whole square. So, let me square and add these two terms. So, here it will be a square plus then it is b square, that is a square cos square phi, a square cos square phi plus 2ab, 2a into b, 2a square cos phi, 2a square cos phi plus this term when we are squaring, this will be a square sin square phi, then RHS has to be squared and added. So, that will be capital A square cos square theta plus capital A square sin square theta. So, capital A square is taken common, then cos square theta plus sin square theta will be 1. So, here we are going to simplify this. Again here A square cos square theta, A square sin square theta. So, A square can be taken common, then cos square phi plus sin square phi also will be 1. So, this entire expression, that is A square, capital A square, capital A, that is the resultant amplitude on the screen. So, we know two independent light sources, the amplitude of first source small a and amplitude of second source also small a, or if you are interested you can write A1 and A2 also. Suppose A1 is equal to A2, then A is the amplitude of individual source and capital A is the amplitude of the resultant wave, resultant amplitude, it is a resultant amplitude. So, that A square is equal to this A square plus and this becomes A square into cos square phi plus sin square phi. So, that also cos square plus phi plus sin square phi is 1, then it is A square plus 2A square cos phi. So, here I can write it as A square plus A square, that is 2A square, 2A square plus 2A square cos phi. So, 2A square can be taken common. So, the amplitude, the resultant amplitude, that is equal to 2A square into 1 plus cos phi. Now, again 1 plus cos 2 theta is equal to 2 cos square theta, or 1 plus cos 2 phi is equal to 2 cos square phi. So, here we have 1 plus cos phi only. So, that will be 2 cos square phi by 2, just a simple trigonometric relations. So, that will be 2A square into this 1 plus cos phi, that is 2 cos square phi by 2. So, we have reduced the expression for the resultant amplitude. A square is equal to, this can be, that will be 4A square cos square phi by 2. So, by looking at this, now we can predict when and where we will be getting maximum intensities, maximum brightness. Intensity that is proportional to the square of the amplitude. Wherever the intensity is maximum, there the amplitude also will be maximum. So, this term can have maximum value, this is constant, 4A square is constant. So, the variation depends upon cos square phi by 2 term. So, when cos square term that is having maximum value. So, we know when phi by 2 is pi. So, cos square phi, cos pi is equal to minus 1, its square will be 1 now, maximum value. So, when phi by 2 is equal to pi, or phi is equal to 2 pi, or for all 2 pi means even multiple of pi. So, generalizing for all even multiples of pi, we will be having maximum amplitude, maximum intensity, maximum brightness. So, n can have any value 1, 2, 3 like that. Then all will be getting the even multiples, and can have 0 also. It means that there is no phase difference. Still, if there is no phase difference, no doubt that point will be bright. So, even multiples of pi. Now, corresponding path difference can be calculated. So, phase difference by path difference is equal to 2 pi by lambda. So, path difference is equal to phase difference into lambda by 2 pi. Phase difference into lambda by 2 pi. So, the phase difference, it is phase difference generally, that is 2n pi. 2n pi. So, 2n pi into lambda by 2 pi, 2 pi will be cancelling. So, we will be getting n lambda, n times lambda, means the integral multiple of the complete wavelength. Or you can say, if you wanted to express in terms of half the wavelength, then that will be 2n, that will be even multiples of half the wavelength. So, we can conclude the condition for obtaining constructive interference, maximum amplitude, maximum intensity, maximum brightness on the screen. It is the phase difference between these two coherent sources should be an even multiples of pi, and the path difference should be an even multiples of half the wavelength, or integral multiple of the complete wavelength. So, in that way the condition of constructive interference is mathematically explained. Now, sometimes we will be getting dark regions also. Dark regions, you know, this amplitude should be minimum. Dark regions in the sense, if we are having two sources of equal amplitudes, then the destructive interference, crust plus trough with equal amplitude, then that will be 0. We will be getting perfect dark regions. But if it is not equal in amplitude, then that regions will be dim, comparatively it will be dim. Anyhow, minimum intensity, you know, cos pi by 2 is 0. So, here phi by 2 is equal to pi by 2, then the minimum we will be getting, or phi is equal to pi, it is just pi, it is not even multiple. In that sense, if I am generalizing, I can write 2n plus 1, it is not even multiple, this is odd multiple, or 2n minus 1, 2n plus or minus 1, any notations you can use. Technically, okay, that is 2n plus 1, generally 2n plus 1. So, the corresponding path difference, that will be phase difference into 2n plus 1 pi into lambda by 2 pi. 2 pi will be cancelling, then that will be 2n plus 1 into lambda by 2. So, it is odd multiples. For all values of n, we will be getting odd values, odd multiples of half the wavelength. We will be getting minimum intensity, minimum brightness, that is a minimum amplitude. So, we can conclude, to get a destructive interference, the phase difference should be odd multiples of pi, and the path difference should be odd multiple of half the wavelength. And to get constructive interference, as we have seen already, the path difference should be even multiple of half the wavelength or integral multiple of the complete wavelength, and the phase difference should be even multiples of pi. So, this is the conclusion. This is for destructive interference, and this is for constructive interference. Just a general representation of the interference, crust plus crust and trough plus crust, like that, this condition. So, if it is a water waves, and if it is light waves, we will be getting bright and dark regions. So, if you are using monochromatic source of light, it should have a single wavelength. Suppose I am using, you know, you can see here. So, we will be getting patterns like this. Bright, there is a central bright region, then it is encircled by that dark regions. Dark in the sense light intensity is very less. In the case of interference pattern, we will be getting concentric patterns like this, and this cannot be explained by the rectilinear propagation of light. It was not possible. So, in which theory are we going to believe? It depends on which phenomena we are considering. So, if it is interference, there should be superposition, and that intensity distribution, that cos square, that 4a square cos square phi by 2, it depends on the wave functions and how the peak and peaks are forming, like that. So, if you are giving a wave treatment to this analysis, then this can be easily explained. So, in this way, the interference, it is explained, its mathematical explanation. Of course, we have the theoretical explanation also. This is the theoretical explanation, mathematical explanation, and now we have the experimental evidence also. And before going to that, for example, so a square is equal to 4a square cos square phi by 2, and this square of the amplitude, that is intensity, so resultant intensity, and here also amplitude square is coming, that is amplitude of individual source. So, intensity I can write 4I dash equal to cos square phi by 2. So, if you are doing an experiment, this experiment, and suppose two sources are there, and if there is a point O, the middle point, this is a screen, then we know the distance to that point, it will be the same, path length remain the same, there will be no path difference, the length remaining the same. So, there is no phase difference also. So, the central point O will be maximum. So, maximum, there is no phase difference, phi should be 0. So, the maximum intensity, this is the intensity of individual source, and this is also the other source, and the maximum intensity let us denote I0, and intensity at any other point let us denote as just I itself, because that can vary. This depending upon the condition, the intensity on that point can vary. So, maximum intensity when phi is 0, we can write that this I0 square is equal to 4 I dash. This, because that time if there is no phase difference, that will be 0, or I dash is equal to this square of amplitude is intensity I0 is equal to 4 I dash, or intensity of one single source in terms of I0 we can write that is equal to I0 by 4. Now, if you are substituting here, we will be getting intensity at any point I is equal to 4 into I dash is equal to I0 by 4 cos square phi by 2. So, I is equal to I0 cos square phi by 2. So, using this you can analyze this maximum intensity at any point on the screen. So, intensity at any point on the screen and the intensity at the midpoint of the screen, it is related by this expression. So, if you are taking this expression, intensity at any point on that screen can be calculated. It is possible to calculate that. So, we can calculate many examples, or before this we had an expression like this. How we are getting this expression? A square is equal to a square plus 2 a square cos phi, like that. So, from that you have made 2a square plus 2a square cos phi, then 2a square into 1 plus cos phi, like that. So, you can check that the previous one. So, this one actually it is a square plus 2a square cos phi, about this expression a square plus 2a square cos phi. So, if square of the amplitude, it is intensity I is equal to intensity of first source I plus intensity of second source. Maybe I can write I1 is equal to I1 and I2, this is the resultant intensity now. So, here that will be 2 into A into A, this I can write 2 into A into A, or A1 into A2. If A1 is equal to A2, then that will be A into A, that will be A square. So, that will be square root of I1 into square root of I2 into cos phi. So, from that equation also you can predict when we will be getting maximum intensity for the given values of phi, and when we will be getting minimum intensity. You can check it. You will be getting that for all values, for all even values, even multiples of pi, intensity will be maximum, and for all minimum values we will be getting minimum intensity, like that. So, see, interference we have mathematically explained. Now, on the basis of this we will be able to consider many questions, and also then it is followed by its experimental proof, Young's double slit experiment. It is nothing but the experimental verification of this mathematical analysis. So, I hope this interference, the concept of interference is very clear to you. So, the requirement is that the essential condition to obtain, first of all, we should have two coherent sources, and coherency is obtained by taking such a sources, means they should have same frequency, and if there is a phase difference in the beginning, and that phase difference should be kept constant. And for all even multiples of pi and even multiples of pi and even multiples of half the wavelength, the point P will be bright. And for all odd multiples of pi, that is the phase term, and for all odd multiples of half the wavelength, the point P will be dark, that is the destructive interference. Okay. Thank you.